Let's take a look at section 8.1. We're going to be completing the square. So what does it mean to complete the square? We have trinomials that we recognize to be perfect trinomials. So we call them perfect square trinomials. A perfect square trinomial, one of the examples is x squared plus 8x plus 16. So there are trinomials that if we were to factor this trinomial, we will end up with two factors, two groups that are exactly the same. So if we were to apply AC method or any other method to factor this trinomial, you will end up with the same group of x plus 4. So if you repeat the group x plus 4 times x plus 4, you can simply write x plus 4 squared. If you have x squared minus 6x plus 9, this trinomial will factor into the same group of x minus 3 times x minus 3. So trinomials that factor into two groups of the same thing, that's what we recognize as a perfect square trinomial. So let me give you one more. If we have x squared plus 3x plus 9 over 4, so if we're dealing with a fraction, this one will factor into x plus 3 over 2 squared. And you can go ahead and double check this by applying AC method or any method you like to factor it and see that in fact you end up with two groups of the same thing. So what we're doing in this section is we're going to be taking trinomials that are not perfect square trinomials yet, but we're going to convert them into a perfect square trinomial to apply the knowledge that we know that it factors into the same group square. So the first few examples, I just want to practice completing the square with you. We don't have to solve it all the way, so let's just practice completing the square. This is how you create a perfect square trinomial. If we have x squared plus 8x, in order to make this a perfect square trinomial, we need to add a number that makes it a perfect square trinomial. The number we're adding is always going to be half of the number of your x term coefficient. So in this case, we look at our x term. The number in front of x is 8. So we take half of 8. So when we take half of 8, we end up with 4. And you take 4 and square it. So 4 squared gives us 16. So that means the number that we need to add here in order to make it a perfect square trinomial is 16. So remember, right now we're just practicing what to fill in to make it a perfect trinomial. So let's look at another example. If we have x squared minus 6x, and we need to add a number to make it a perfect square trinomial. The number you add, it's always half of the number in front of x. So in this case, we're taking half of the number in front of x now is a negative 6. So half of negative 6 is negative 3. And you have to take your negative 3 and we have to square it. So negative 3 squared gives us a positive 9. So the value we're adding here to make it a perfect square trinomial, it's positive 9. Let's do one more like this. So if we want to complete this trinomial to make it a perfect square trinomial, let's say we have x squared minus 7x, and I want to make it into a perfect trinomial. So we have to take half of the number in front of x. So in this case, we're dealing with negative 7. Half of negative 7, so remember this 7 is understood to be over 1, so we multiply fractions straight across. 1 times negative 7 is negative 7 over 2 times 1 is 2. And in this case, our fraction doesn't reduce. 2 doesn't go into 7, and we cannot reduce our fraction anymore. So just leave it as negative 7 over 2. And once you take half of the number in front of x, you have to take the result. So we take negative 7 squared, negative 7 over 2, and we square it. And we use the rule that if we have a fraction square, means you have to take the top and raise it to the power, and you also have to take the bottom and raise it to the power. So we end up with negative 7 squared gives us positive 49. 2 squared gives us 4. So that's the number we need to add here, 49 over 4, in order to make it a perfect square trinomial. So half of the number in front of x and square it. That's how you complete the square. The process of completing the square helps us make it a perfect square trinomial. So now that we have some practice on how to do this, now we're ready to go ahead and solve a few problems. So we're going to be solving the following problems. So let's start by solving x squared plus 2x equals 4. So we want to go ahead and solve for this quadratic by the specific format of completing the square. So we have to take x squared plus 2x. When you complete the square, you get your x squared and your x on the same side by themselves. So they're currently on the same side by themselves. So we're going to leave the 4 over here, and we're going to end up having to add a number. But when we're dealing with an equation, whatever you do to one side, you must always do it to the other side. So whatever number we're going to add here, we're going to have to do it to the right-hand side of our equation. So the process is you take half of the number in front of x. So we're going to take half of 2. So half of 2 gives us 1. And we take whatever value we got there. In this case, we got 1, and we have to square it. So 1 squared is 1. Here is my advice. Go ahead and simplify because you can see that the number we have to add is 1. So we're going to end up adding 1. When you're writing it here, I highly suggest that you keep it in the format of the number square. The reason we're going to be doing that, because if we do this, the way this factors, now we're ready to go ahead and factor. The way this factors is, it factors into, we know it factors into the same group, so it factors into a group square. Take your variable, our variable we're dealing with is x, and take the number inside the parentheses here. So the number inside the parentheses is a positive 1. So this trinomial, it's a perfect square trinomial, and it factors into x plus 1 squared. The right hand side, you just simply add like terms. So 4 plus 1 is 5. So now that if we factor it like this, now we're able to solve it. And we're going to solve it by using the square root property. So remember, the square root property says, if we're dealing with the square of a group, the way to get rid of a square is to do the opposite operation of a square root. If we take the square root of this side, we must take the square root of the other side, but we always need a plus or minus in front of the square root. So this one undo each other, so we're left with x plus 1 equals plus or minus. Square root of 5 doesn't simplify anymore, so we simply write plus or minus square root of 5. We're solving for x, so we subtract 1 to both sides. Because of the plus or minus, you cannot combine them. And even if we didn't have the plus or minus, this is an outside number, this is an inside number, right? So we simply write negative 1 plus or minus the square root of 5. You still have to recognize that we have two different answers. X can be negative 1 plus square root of 5, or x can be negative 1 minus the square root of 5. So you can write your answer as the two possible answers, or you can leave your answer like this. You just have to understand that we have two different options. Let's keep doing a few more. So now let's go ahead and solve p squared minus 3p plus 1 equals 0 by completing the square. So if you're completing the square, your first goal is to get your p square. In this case, we're dealing with p, so it's to get our square and our p terms by itself, because we need to add a number to make it a perfect square. So that means we have to get rid of the 1. So we're going to get rid of the 1 by subtracting 1. So now we're left with p squared minus 3p equals -1. Once you have your square and your p term by itself, now you can complete the square. So here's where completing the square comes in. We take half of the number in front of p in this case. So the number in front of p is -3. 1/2 of -3 is simply going to be -3/2. And we have to square it. So we take -3/2 and we square it. So we have -3 squared is going to become a +9, and we have 2 squared is going to become a +4. So the number you add on this side, keep it in the format of -3/2 squared. The number we add over here, you can use the simpler form of 9/4. And now you're ready to go ahead and factor. So that means the left-hand side is going to factor into, we're working with the variable of p, and you look at the number inside the parentheses. The number inside the parentheses is a -3/2. So we write p minus 3/2, and we're going to square it. Because by doing this process, we know we created a perfect square trinomial. Here we end up with -1 plus 9/4, so you have to do a little bit of side work, right? So we have -1 plus 9/4. In order to add fractions, we need a common denominator, so we need to multiply this by 4. So we end up with -4/4 plus 9/4. We have a common denominator, so we keep our denominator of 4. We add at the top, -4 plus 9 gives us +5. So this right-hand side simplifies to 5/4. Now it looks like something we've been doing before. Now we're able to solve, and this is by the square root property. So the way we get rid of a square, opposite operation, is to take the square root, but every time you take the square root of the other side, you have to add a plus or minus. They undo each other. We're left with p minus 3/2 equals plus or minus square root of 5/4. Here, if you can simplify this more, you can go ahead and simplify this a little bit more. Because if you can see, if we have square root of 5/4, it's the same thing when we're using our properties of square root of 5 over square root of 4. And you can see the square root of 4 can be simplified to 2. So I'm going to go ahead and rewrite plus or minus square root of 5/2. We're trying to solve for p in this case, so we need to get rid of the 3/2 by opposite operation of adding 3/2. So we end up with p is equal to, you can now combine them, positive 3/2 plus or minus square root of 5/2. So you can leave your answer like that, or you can combine it as a single fraction, because you can see they have a common denominator of 2, so you just take your top is 3 plus or minus square root of 5. So either answer is okay with me. Let's look at the next example. Let's try to solve. Let's go ahead and try to solve y squared plus 2y plus 2. So this is similar to example 2, so I want you to go ahead and pause the video and give it a try on your own, and then if you get stuck somewhere in there, it's okay. Just try to at least complete the square on your own. Alright, so hopefully by now you already have tried this on your own. So remember, you have to get your y squared and your y by itself. So we're going to subtract 2 to both sides. So we end up with y squared plus 2y equals to negative 2. Now we're ready to complete the square. So we take half of the number in front of our y. So we're taking half of 2. So we end up with 1. And we take whatever number we get there. In this case, we got 1. And we have to square it. So the number we're adding is 1. Here, go ahead and write it with the square. So we have 1 square. So I know is going to factor into our variable y. The number in front of the parentheses there, it's a positive 1. So we write plus 1 squared. Equals to, we have negative 2 plus 1. We end up with negative 1. So we get rid of our square by taking the square root. We must use plus or minus in front of the square root on the other side. They undo each other, so we're left with y plus 1 equals plus or minus, and you have to remember this one, square root of a negative 1. We cannot take square root of negatives, but we know square root of negative 1, we represent it with I for imaginary numbers. So we end up with plus or minus I. We try to solve for y, so we have to subtract 1. So we end up with y equals negative 1 plus or minus I. And that's our solution. I have one more. Let's do one more for this section. So let's say we have a squared plus 4a equals negative 6. So we don't have to move anything. Our a squared and our 4a are already by itself. So we simply write a squared plus 4a and we get ready to complete the square. So we take half of the number in front of a. So we take half of 4. Half of 4 is 2. And we have to take 2 and square it. So 2 squared is 4. Remember, don't simplify it yet, just simply write 2 squared. The reason why we simplified it more is because over here I know I'm going to have to add 4. The reason we don't simplify is because when we factor, our perfect square trinomial factors into your variable, the number in front of the parentheses, so it's a positive 2, so we write down plus 2 square. And this is equal to, you can simplify the right hand side, negative 6 plus 4 is negative 2. We need to get rid of the square. Opposite of squaring something is to take the square root. When you take the square root of the right hand side, you need plus or minus. They are opposite to each other, so they cancel each other. You can think about it like that. So we end up with a plus 2 equals plus or minus. Here we're dealing with the square root of a negative 2, so this is the one where you have to think about it. We can always rewrite a negative number inside a radical as negative 1 times 2. And the reason we do that is because we know square root of a negative 1 is going to be I. We cannot simplify square root of 2 anymore, so we simply say square root of 2. So this simplifies into I square root of 2. Now we're ready to solve for a. We have to get rid of 2 by subtracting 2. So we end up with a equals negative 2 plus or minus I square root of 2. So that's all I have for you for this section. You should be able to complete your homework now.